Ok, depois não se entolacha. Hello, everybody. That was quite an explosive start. Welcome to our first pre-event of this series of pre-events for the Slovenian Global Game Jam, where we will try to basically teach you and prepare you for the game jam, so you will make an awesome games. And before we continue, I would like to say that this event is created and organized with our friends from MC Rook and Kibla 2 Lab, and also Festival Kiblix. And I also like to thank all of the people that helped me to make this event happen. Giga, Maya, and Doman, thank you for putting out of effort these past 2 months into this project. And now, before I continue and before I stop babbling, I will just say that this event will be mainly on Discord. So Discord will be our main hub for this event. So I would like to invite you to join the Discord group, and here you can meet an awesome community of like-minded game developers, which are very, very welcoming. And now let me introduce our speaker, Miha Rataj, who is a principal software engineer at Equipa2, which is a subsidiary of Outfit7, and he has been making making games for past years. And one of the most known are Talking Tom Goldrun, and he's currently lead dev on an unannounced project. And without further ado, I will give word to Miha.
Hello. So yeah, thank you, Rock, for the introduction. I hope you can all see my screen. I will start sharing some slides. So yeah, basically I will start with the slides, but later I will switch to Unity. We will hopefully have some live action as well to make this presentation a little bit interesting. But yeah, first a few words about me to introduce myself a little bit. Like Rock already said, I'm a game developer for the last 4 or 5 years, let's say. I work at Equipa2, which is a subsidiary of Outfit7. Before I joined game development, I was a mobile developer, web developer. So across the last 10 years, I was working across different fields, different technologies. I am enthusiastic a lot of stuff besides programming. So yeah, let's start with this presentation. I think it was enough of the introduction. Let's check what we will talk today. Well, mainly we will talk about how to do more with less effort. When Luke asked me, can we do some presentation? I was, of course, okay, what we can do in 1 hour, what we can show. And to me, it's really important, not just in everyday life when working, especially, for example, for the events like game jams. For me, it's always important how to do a lot of stuff, with less effort, because usually time is the problem and you don't have a lot of time and you want to do a lot of stuff, right? In this presentation today, we will go through some Unity features. It's going to be basically like a walkthrough. We'll not go into too many details because we only have 1 hour. Hopefully you will get some ideas, what are the features from Unity that you can use on the game jam or in some professional or personal life. That will make things easier for you. So when walking through these features, I will show some tips and tricks. And some of the stuff, I will just mention. Some of the stuff I will have some detailed explanation maybe on slides. And for some things, we will also show some live things in Unity just to get the idea how powerful some features are and what we can actually do with them. Yeah, like I mentioned, it's not going to go into, we're not going to go into many details, but this presentation is more like for you, to get the basic idea, what features exist and what you can do with them. But of course, if you will want to learn them, I recommend you to spend some time later, reading documentation, checking some videos, when you will actually need to solve this kind of problems. Because maybe, for example, in the game jam, you will not need all of these tools, maybe you will, but most probably maybe already 1 or 2, would be very helpful for you when participating on the game jam or somewhere else, like I already said. So we will start with Unity Pro Builder. Then we'll continue with Animator controller. We'll check the what we can do in Unity, to control our character, to move it around through the game world. We will quickly check the Cinemachine, which is basically a Unity package for manipulating the camera. We will check what techniques there are in Unity to navigate our, let's say, agents. So agents is like a fancy word for the characters, usually computer-driven characters in the game, which you want to move in the 3D world. So basically, in Unity, you have some ways how to really easily drive these characters across the 3D world. And at the end, we will check also some things that you can do with Unity physics. And I'm really interested, in the character animation. So basically, we will also quickly check, how you can do a ragdoll effect in Unity really easily. Okay, good. So let's start with the first Unity feature that we said we're going to cover. The first one is called Unity Pro Builder. So what does the Unity Pro Builder offer to you? It's basically a set of tools that you can use directly in Unity to perform a quick 3D modeling and level design. So it's similar how you can use any sort of 3D modeling software like Maya, Blender, You can also use Pro Builder, but the main advantage is that you can use this directly in Unity. So you don't need to switch, to some other 3D modeling software in order to produce some basic 3D objects, right? You can already do them in the Pro Builder. So because of this, it's ideal for quick prototyping. And with using Pro Builder, you can do some really simple structures really quickly. You can sketch up some simple terrain. You can do some, simple vehicles modeling or weapons modeling. And yeah, like I said, you don't need to switch to some 3D modeling software in order to do that, which is basically the main advantage by using Pro Builder. It offers also some set of tools, for manipulating the UVs or vertex painting, so you can also paint these 3D models, And although you don't need to, but you can still integrate it with the 3D modeling software, right? So you can use ProBuilder and then switch to Maya, for example, right, to do something more advanced, right, and then go back to the to Unity, to ProBuilder, you know. So this is like a really powerful tool which you can use mainly for the prototyping, I would say. So yeah, like I already mentioned, you can do some prototyping. It's really easy to do. Like if you have some basic 3D modeling skills from some other software, you can utilize these skills here in the ProBuilder. And yeah, like you can see on this GIF, it's really easy to use. You can also use ProBuilder in order to sculpt some 3D models. So basically produce like a very interesting shapes really easily. And what ProBuilder also offers to you is some basic, let's say, shapes, you know, for example, stairs or some other stuff that you can procedurally create here by clicking this build button here that you can see on the screen. And the beauty of this is that Unity will also create, for example, mesh collider for this 3D object, and also it's really simple to use this 3D object which you create using ProBuilder, then together with other Unity features like physics, colliders, navigation, and things like we will see in the future. Yeah, like I said, you can also use ProBuilder to paint some 3D models. And at the end, while combining all these tools together, you can produce some objects like this, right? So you can use it not just to create a 3D world, but also some sort of levels, right? So like I said, it can be also used for the game design. And you can also produce some like 3D models like we see here on the screen. The last thing I will mention about the ProBuilder, that it's not available in standalone Unity, but it's really easy to get it using the package manager. So I can switch now to Unity to open some project, and then we will check the first thing in Unity where you can find the package manager and how to use the package manager. Yeah, so basically here I'm creating a new Unity project. Like, I will call it package manager. I click create. This takes a little bit of time, but it will create an empty Unity project for us, which we will use to show some stuff later. Okay, while my computer is creating a Unity project, yeah, it was quite simple. I can already go to the next slide, which is mentioning Unity Asset Store. So Unity Asset Store is a similar thing to Unity Package Manager that we will see right now. So you can use both Unity Asset Store and Unity Package Manager in order to get some stuff from those platforms which is already made. So one of the examples of what you can get in the Unity Asset Store or Unity Package Manager is basically some set of 2D or 3D assets that you want to have for your game, or some set of sounds that you want to use in your game. You can also download some SDKs, for example, if you want to for example, create a multiplayer game. You will find some multiplayer tools maybe in the package manager, and maybe also some templates. So basically, it's really powerful stuff which you can use. So where to find the Unity package manager and the asset store? you will find it here. If in Unity, if you go to Window, you see Asset Store and Package Manager here. And for Asset Store, you will need to have a Unity account. I think so. You will need to be signed in, and you can use these things really easily. So if you open Package Manager, for example, here, if you go to Unity Registry, here you have a lot of tools from Unity which you can use, and some of them I will also explain later in the future. But just to wrap up this thing about Pro Builder. So for example, the Pro Builder, you can also find it here in the Package Manager, and you can use this search here in order to find it. Okay. Pro Builder is here. So if you want to get it to your project, you simply click install here. And from that moment on, you can use Pro Builder in your project, and it's really simple to use. I will just quickly show some stuff, and then we proceed with other features. So once it gets imported, you can close the Package Manager, and then in the Unity menu here, you will see tools like a Pro Builder window. And what this does, it will open some Pro Builder window, which is basically what we saw before on the slides. And then you can use these tools in order to create your 3D objects here in your scene where you are. Okay, enough about this Pro Builder. I think you got the basic idea how you can use it. Let's continue with the Animator. So basically, for those who are familiar with Unity, you probably already know about the Animator. So we will go really quickly around the Animator. So what Animator allows you to do is play some animations, and these animations can be what I'm trying to say is you can play different set of animations on your object, and this object is usually a character. So each character will have different states. For example, idle when he's standing still, then walk state when he's walking, and shoot state when he's shooting, for example, right? And in the Animator in Unity, you can actually define those states and then link those states, with specific animations that you get usually from the Animator. Right, and then you can also in the Animator you can also then configure, the transitions between those animation states, and you can also configure the blendings, different layers of the animation, and things like this. So I suggest we just quickly show how we can use it and how to work with it. So basically, I prepared here in the Package Manager. Before this presentation, I already prepared one. I already searched online in order to find some 3D character, which also has some animations included in this package. So basically, I found this on the Unity Asset Store. So this is basically one example how you can use this Unity Asset Store. And then once you have this. Once you buy this thing, because it can be, it can have some price on it, or it can be free, you can basically open this in Unity, and it's really simple. Like Unity will open this package manager for you, and you will find this package, which is called Humanoid Avatar Rig 3. And I guess we need to wait a little bit in order for Unity to refresh. Oh yeah, maybe we need to help him a little bit. Okay, I have this humanoid avatar rig 3, which I will import using this button here. I will click import, and then here I select what I want to import. I will just select everything, click import. And then after the import is finished, in your project window here, you can see your assets that you just imported, right? So this humanoid avatar, it was imported under this humanoid avatar folder. And basically, you can inspect what you got here in this package, right? So Here we can see that we got some rig for the character. We can also see the preview of the character here. And it looks like this package already provides us some prefab with this humanoid character on. So I will just basically drag and drop this character into our scene. And yeah, here you can see our character, which is not nicely lit. So let's just rotate this light a little bit. Okay, so now we can see our character here in the scene, right? So if I click on this prefab, you will already see that we have inside of it, we already have this skin mesh renderer, which we got from this rig here. And we also have the Animator controller attached. And the Animator controller is basically the entry point where you can modify a board, where you can work with defining the animations for this character. So looks like this package already provides us with some demo animation controller. I will basically just delete that, so you see how this thing can be set up from scratch. And instead of using this existing Animator controller, I will actually create a new one. So I will go here, I will click, right-click Assets folder, I will click Create Animator Controller, and I will call it Animator Character Animator Controller. Okay, and if I double-click this Animator Controller, what Unity does, it opens up Animator window where we can define the animation states for our character. And let's say that we don't want to overcomplicate this now. We will just create the two states. So right-click on some space here, create a new state. Let's call it idle. And then I will also create one other state. I will name it like walking, right? And then I will link those two here. So basically, I will create a transition from the idle to the walking and back from walking to the idle, right? Now I need to tell here how I'm gonna actually do these transitions, right? Because when the character is standing still, I want to, I want to play the idle animation, and then when he starts walking, I want to play some walking animation here. So I will do this by defining some parameters. So I will click here parameters, and then I will click some create new Boolean parameter, which I will call walking. Okay, and by default, it's going to be false. So our character is going to be in the idle state because this is the default idle state, and then it's not going to go into the walking because basically this walking here is false. But yeah, let's define now the conditions so that Unity will know when we want to play the walking animations. So basically, I will click on this transition here from idle to walking. I will click conditions, and then I will select walking here and set it to true. So that means that as soon as the walking is set to true, then we go out from the idle, and then we play the walking animation. So what I need to do here also is untick this has exit time, which basically just means that whenever this walking is set to true, I will go from the idle to walking, and this is it. And okay, let's just define quickly same thing for the vice versa animation transition. So when the character stops walking, it will go. So that means that walking parameters is set to false. It will go back to the idle, and then it will play the idle animation. So now I just need to tell Unity which idle animation I actually want to play on the character when we are in this idle state. So here I can define the motion for this idle state, and I will just define the motion to the idle animation, which is basically inside here. So I can either drag and drop or select the idle animation here, and then I go to walk. I will do the same thing for the walk animation. And one other thing that I need to do is also I need to set this idle animation to be looping animation, right? Because basically this is the idle animation. I can preview it here. And when the animation ends, right, we automatically want it to continue from the beginning. So basically that means that it's looping. So I will just enable looping here, and the same thing for the walk animation. So walk animation, loop time, apply. Okay, and this is it. So by default, in the play mode, now we should be in the idle animation. Let's see if anything happens. Oh, yeah, probably I forgot something. Yeah, of course, I created this character animator controller here, but of course I didn't link it yet with the animator here in the scene. Let me just do this. And then now I save this scene, I press play. Hopefully it's gonna be playing now. Okay, so now we can see this idle animation, which is playing on the character. It's gonna be looping, so I can also preview my animator here. So if I click the character here is the animator, but now if I want to see the animator, I need to click animator here in Unity, and you will see that the idle animation here is looping. And then if I set this walking to true, right, he will start walking the character, and when I set it to false, right, it's gonna go back to the idle. And this is our animation state machine. And of course, what you usually do in the code, you will basically just tweak these parameters here, right, in order to switch between some different animations. And of course, in the practice, you will have a lot more animations here, but it's something like the whole animator component is something like that you can really simply use in order to get some nice visual effect on your screen. So this is really nice to use. Okay, let's go back to our presentation. Okay, one of the good things in Unity is also the character controller. The character controller you can use in order to move your character in the 3D world, right? Because in our example here, in Unity, right, if I go to the play mode, although the walk animation might be playing when I press walking here, right, but the character in the 3D world space, right, is still standing still, right, because his position in the world space, it's gonna stay the same, basically, right? So here you can actually use then the character controller. And the beauty of the character controller is, because some of you might ask, why I should use character controller and not just, for example, set this position in the code based on the input, right? The beauty of the character controller is that it will work, with the other objects that you have in the scene. So, for example, if you would have some 3D cube here, right, and this cube would have a collider attached on it, right? So that means that when this character, would actually would walk here, right, it would actually collide with this cube, right? Because in the game, probably we don't want something like this. We want that the character stops here, right? So the collider here will actually allow you to define, that the character needs to stop here. But if you will set the position, to here, this collider will not have any effect, right? But if you use the character controller, and the character controller, you can use it really simply. So on your character, you basically just add new component, and you see that the character controller is then found in the list of already made components. And then in the code, basically what you would do, I will not do it now because we will run out of time otherwise. But what you can do is just define, like character.move, and then you would call a function where you say, I want to move character maybe a little bit forward, And then the character controller would actually contain the logic where it would say, but I cannot really move forward because I have a collider here. So I will not actually move forward, and I will basically just stop here. Yeah, maybe we go to the question at the end whether we will actually go to the ragdoll also. And yeah, with the character controller, you can also define some other stuff. For example, like slope limit, step offset, and things like this. So where this comes handy is actually where you have some sort of colliders, you know, like this, right? Where you actually have the slope, and then in this case, what you would want maybe is that your character actually would go up on your slope, right? Just like on the stairs, you know. So basically, the character controller will also provide you this logic. So it's super simple to use if you want to have some movement on your character, basically. And some other properties that we already see here, that we already saw here on the character controller, right? So yeah, basically here you are defining basically the collider, let's say, for your character. So here it's a little bit off, but you could set it here, right, with these offsets here, and then the radius and the height. But yeah, you can also have some other things. For example, like is character grounded? So, for example, if the character is touching the ground or not, and what's the velocity of the character, and then these methods, then which are already mentioned, which you can use for moving the character. So, yeah, basically that's a character controller. One of the problems that also arises usually when you are working with the movement of the character, right, is that you would usually want that the camera would actually stick to the character, right? So in our case here we have the camera in the scene, right? But this camera is completely static, right? So if the character will now move, you know, in some other direction, by default the camera will not follow this this character, right? And of course, your game is not really the best game, right? If you are unable to see the character. So what you can do in Unity really simply is, if you have the character here, you can basically just, you know, child the camera, position the camera under the character, right? So that means that when you will move the camera, when you will move the character, you know, in the code or with the character controller or whatever, the camera will basically follow him. And this is what actually is happening here, right? You can see here the frustum of the camera, which is with these gray lines here. And what you can do is, of course, move the character, and yeah, you will see that the camera is moving together with the character. So you can actually see the preview of what is happening here. Once I move the character, the camera is also moved together with the character. But sometimes you want to do some other stuff with your camera, right? So for example, sometimes you want to have the sticky position of the camera. So that means that the camera is always static, so that it doesn't really move, right? But instead, you would want to have that the camera would follow the player. And by following the player, I mean is basically that it's just looking at the character, right? So this is similar to, let's say, if you watch football on the game, right? On the TV football game, you would usually see that a camera would follow the ball, right? And it's not actually following it by the position, but it's basically just rotating the camera, you know, so that you can still see where the ball is, right? And for this, of course, you can do this in the code, right? Basically, you would detach the camera here because you want it to be, you know, on the static position. But then in the code, you would actually rotate it in a way so that it would, you know, follow your character. But the thing is that you actually don't need to do this, right? Because yeah, like I already mentioned, there is this tool called Cinemachine, and Cinemachine is again a package, just like a Pro Builder, which you can download and then install into your project, and then you can use the Cinemachine in order to define, how your camera movement should be like, and all this stuff. And the Cinemachine will actually already provide you some set of cameras, for example, to cover these most frequent scenarios. For example, these scenarios that I mentioned with moving the camera position, with changing the camera rotation in order to achieve the effect of, look at effect. So you can do this with Cinemachine without actually any code. And you can also blend, between different cameras. So, for example, let's say that you have a character, right? And let's say that a camera will be following your character, with the position. So it's gonna actually stick to the character. But then maybe in some scene, what you would want is that camera just stays there at the same position where it already is. And then the character maybe moves forward, and then the camera actually is now changing its behavior. So basically it's just, now on the sticky position, and now it's basically just, looking at the character, maybe also zooming in a little bit. So with Cinemachine, you can do this without actually any code, or maybe for blending you would need some code, but it would basically just mean, activate this camera and that's it. You don't need to tweak the positions, to tweak the transforms, the rotations, and all that stuff. It's really simple to use. And what is also really nice to have is that you get this cinematic effects for free. So, for example, on preview here, which I have here in the slides, you can see that the camera is basically following the character, right? Like, I mean, the position. But you would sometimes see that the position is delayed a little bit, right? Based on the movement, right? So this is what happens usually like in real time, right? Because the cameraman doesn't know like where the character will move actually, right? And with Cinemachine, you can get this kind of effects for free without any code. So in order, to include the Cinemachine in your Unity project, the process is really similar as we had it before with the Pro Builder, right? So you go here to the in Unity, you click Window, then you go to the Package Manager, and then you go to the basically, if you go to Unity Registry, you will see all the assets. All the packages which are already provided from the Unity, and you can click Cinemachine here, and then you click Install. And what you will actually get in your project is another menu here on the top, using which you can actually use these cameras that you get from the Cinemachine. Okay, so when the Unity stops importing stuff, basically you can go here in the menu. You will see that you have now this Cinemachine option, and then you can add, for example, I don't know, virtual camera, for example, right? And when you click this, now your camera is actually, you still have the main camera here, but you actually control this camera with this camera now, right? Because on this camera, you can see that this Cinemachine drawing is now attached, which just means that this transforms and all that stuff, is driven from Cinemachine cameras. And currently we only have one Cinemachine camera. So basically here you can basically define what do you want to do with the camera. And here you can define, for example, the follow property, like for example, the camera, the character which you want to follow, or the character which you want to look at. And then you can also define, for example, some properties like damping and offsets of the camera and things like this, in order to tweak your camera position offset based on the character. And yeah, that's it regarding the Cinemachine. It's really simple to use, so check it out if you want to move your camera. Okay, let's continue with our presentation now with some other features. Yeah, let's check the navigation system. So navigation system is, again, a really powerful system which you can use and actually get some effects without writing much code, and it's solving, quite, I mean, the problems which can be quite complex. Maybe, for some beginner, for example, the pathfinding, would maybe take quite some time in order to implement, of course, based on your skills, right? But in Unity, the beauty of this navigation system, which is already provided from Unity, is that you don't really need to write almost any code in order to benefit from this navigation system. So where do you actually use the navigation system? The navigation system, you would use it where you want to have some pathfinding. So for example, imagine a game where you want to say, like a click-through game, like a clicker game, right? Where you say, okay, now I want my character to go to this position, right? And or to go to this position or to this position, right? So basically, you're clicking. You can see the mouse actually codes right here. So the mouse is telling the character, I want the character to go here. And of course, this, if you don't have any object in the scene, it's quite simple, right? Basically, you just do the linear interpolation between 2 points. But when you have some other objects, just like, some obstacles on the way, and this can be either static or dynamic, right? This process, then, it's more complex, right? Because you need to include all these cases then in your code, right? And in Unity navigation system, how this is solved is basically that you define some sort of navigation mesh, where you say these are the obstacles where I don't want, which are not walkable actually, so the character cannot walk on these obstacles, right? So basically he needs to avoid these obstacles, right? And then you also define the agents, right? So the agent is actually, in this case here, we only have one agent, right? So one agent is this green thingy on the screen, right? And in the game, you can have many agents, right? For example, if you would have 10 opponents, for example, right, you would have 10 agents, right? So once we define the walkables area, the non-walkable area, the agents, we can then actually really simply just start moving the agent position, to the destination. And we will see now how easy this is. I will go back to Unity. I will define a some new scene for that. So let me create a new scene. It's here, okay. And I will call it, let's say, navigation. If I open it, now it's an empty scene. It only has a light and the camera. So I will create some plane in it. So this is let's set the position here. Yeah, so this is basically our floor in our 3D world, right? I will maybe just increase this a little bit. So it's like this. And then on this floor, I will create some obstacles, right? So for example, you can imagine these obstacles to be just some sort of walls, that we have in our map. Okay, I have one cube here. Let me also create maybe some material. It's going to be easier for you to see what is the cube. Let's create some green material. Like this. Okay, I will link this material here. Okay, so we have our cube here, and it has a green material, and let me just basically duplicate this cube, because maybe we want to have some more obstacles, right, in order to see how our pathfinding is working, right? So what I can also do is something like this, some variation, and do something like this. Okay, that's, I guess, enough for the sample. So on this cube, you can on these cubes you can actually already see, right, that Unity attached the mesh renderer on it, right, and the mesh in this case is basically a simple cube, and then the navigation system in Unity will actually use this mesh here, to define the walkable areas, right? So how we can start defining our navigational world, actually? We can start defining it here. If we go to the window, and then if we go to the AI, you will see this navigation. And once you click on it, you will get another window open, which is called navigation. And then here you have a few tabs where you can define your properties. Let's not just worry about those for now. Let's focus now on defining the walkable and non-walkable areas, right? So in our navigation window, we will go to the object, and basically we will define that we want to create this navigation mesh, which is basically our walkable area based on these objects that we have in the scenes. And these are actually the 4 objects based on which we will define our navigation mesh. So I will select them, I will click object here in the navigation window, and I will select navigation statics. I will mark it here, and then I will actually, in the navigation area, now I need to define, our plane is actually walkable area, so the character can actually walk on this plane. But these cubes, right, are basically our walls, let's say, right? And I will say that these are not walkable, right? Because the character, let's say, cannot walk on this, because let's say that these are our walls. I will actually increase them a little bit like this. Okay, so now we have our, our properties of our 3D world defined. So now I can go to the bake section, and what I will do is I will click bake. And what you see that Unity provides is it creates a navigation mesh, and this navigation mesh, you can see that it actually, avoids these walls here, because we don't want that that our agents, the characters, will walk inside this area. And the same thing goes for this pillar here, and the same thing also for this wall. So here, like I already said, you can also define some properties. For example, what's the distance from these non-walkable areas and things like this. But let's not worry about this for now. Let's just create our agent also. So to create our agent, I will create some capsule which will represent our player, and this is our player. And then you can see that Unity already creates a mesh renderer for it, so we can see it. And besides this mesh renderer and the collider, we will also add the navigation mesh agent, navigation mesh and agent component. And here we can actually define some properties. For example, what's the speed of this agent, what's the angular speed, what's his acceleration, and things like this. But yeah, let's not worry about this now. What we need to do now in order to start moving this agent in our code is actually we need to set him some destination, right? So for example, if we want that this guy will move from this position to this position, we somehow need to define, this position. And how we will define it with code, but you will see that it's really simple, almost no code. So I will create a new script. I will call it, let's say, player controller. And then I will open this player controller script in my code editor. And yeah, let's edit script. Yeah, this sadly takes a little bit of time, but should be quite fast. Okay, and in this player controller, what I will do is I will create a property for this component. How is it called? Nav mesh agent, right? Nav mesh agent. And oh, you don't see my screen. Let me share it back. Okay, I have no idea what happened, but okay, let me continue. So what I did is I created a player controller script here, and yeah, let's not worry about this. And in this player controller script, what I will do is I will set a destination of this agent, right? So I can set my destination really easily. So in the update method, I will call on this agent. I will call a method called set destination, and you see that we receive the vector 3, which is a target position of this agent, right, where I basically want our agent to be. So I will set this destination based on some other object. So let me introduce some destination transform here. Then I will use the position of this destination object, in order to drive the position of the our character. So let's go back to the Unity. So here I will actually now create a new, let's call it a destination transform. And yes, I will move this destination transform in the world, I don't know, somewhere here. Okay. And I basically now I just need to link these two properties. So I will link this now mesh agent, and I will also link this destination transform. And now, hopefully, if I go to the play mode, our agent here will actually automatically follow, this destination position. And now, also, if I move this destination position, it will actually follow this destination position. And what you can see is, if I drag this destination position to here, our character will actually avoid the wall here, which is basically defined as non-walkable area, and it will still go to this destination position, right? And this really is it regarding this navigation system that you can use in Unity. It's really simple to use, and then you can play around a lot with these properties here if you want. Then also define some dynamic objects. But of course, if you want to explore more of this navigation system, there is plenty of materials online. So basically, you can check it on your own. Okay, let's go to our slides. Since we are slowly moving towards the end of the presentation, I will be a little bit quick because, yeah, 1 hour time, it's not that much actually to explain some technical details, but yeah, let me just discuss also some things about Unity physics. So Unity physics is actually, those familiar with the game development, you're familiar with the physics, right? So that you can have some objects, in your scene which follow the rules of the physics. So for example, if you put some box, for example, on some high position in your 3D world, right? And then you put a rigid body on, which basically means that you want this object to follow the principles of the physics, right? In the play mode, what will happen is that this box will actually fall down in the scene, right? Because your gravity is usually set, just like in the real world, so that your objects fall down. And then with the colliders, you basically define what are the boundaries, right? So for example, if you have a box here and then another box here, right? And both boxes have a collider on it, you are basically defining that one box cannot go into another, right? But basically these boxes, when they will actually meet, in the 3D space, they will actually collide and they will bounce off of each other, basically, right? And you can also use these colliders in order for some triggers, right? For example, you maybe want that the character dies, when the bullet hits him or something like this, right? So you can also use Unity physics in order to do this. And I'm sure you are all more or less familiar with Unity physics. It's really simple to use in Unity, so I will not actually mention it here and show it here, because it's really simple and you guys already know a lot about it. But what I will mention is that in Unity you also have a lot of different colliders which you can use, for example, especially in 2D games, for example, right? You see some sample here which is similar to the Angry Birds game. I think you're all familiar with it, right? And you have this kind of behavior here, right? That you can actually shoot this ball in the air, right? Using this catapult, right? And this is really simple to do, like in Unity. If you are using this, I think it's called spring constraint or something like this. I'm not really sure, but you can do this kind of stuff already, with Unity colliders. And this kind of stuff, if you want to do it in the code, fine, you can do it, But all I'm saying is sometimes, quite quickly it will happen that once you start coding, it's like really easily to spend 1 hour or two. But maybe with this, with using these colliders, maybe you just spend 5 minutes, or 10 minutes in order to investigate a little bit, and then maybe just put 1 or 2 lines of code, and that's it, right? So what I suggest to all of you who are not familiar with this, that you investigate, what kind of constraints you have in Unity for the physics. So for example, here, if I add component, right? If I go here to the physics, right? You will see that you have a lot of different shapes, like this different colliders, and then this spring joint and hinge joint, and then this constant force, for example. And these are really, really easy to use. And usually what people are doing is they are writing custom code for this kind of stuff, but you don't need to. So basically, just check this stuff online, because it's really simple to use this kind of stuff. And yeah, let me also mention the ragdoll effect, which is really easy also to do in Unity. So before we had a sample with the character, right, which was animated using the keyframe animation in Unity. So that means that actually the animator defined our idle and walk animation, for this character guide that we had before in Unity, right? But together with Unity physics and ragdoll wizard that you can find in Unity, you can also define a ragdoll effect really, really easily. And once you do it, you can really simply achieve effects like this, right? When you have this character falling down, for example, when the bullet hits him or something like this, right? So let me show also this, and then we will wrap up this presentation, because yeah, this is, to me, it's really cool stuff that you can do with this. So let me drag our character here in our scene once again. So okay, let's move it here. Okay, and we have this character here now in our 3D world. Let's move it a little bit up, right? Because let's do it like this, because we want to see, the effect, for example, when this guy falls down with the ragdoll effect. And how you can create your ragdoll effect in Unity, it's really simple. When you already have the rig ready, you will have some sort of game objects here that you can see in the hierarchy. For example, hips, like left up leg, left leg, and these are basically the the joints, the skeleton of our character, right? So when defining the animating the character, right? So this kind of stuff will be actually animated through the keyframe animation, like in example that we had before, once we were playing this idle and walk animation. But in the ragdoll effect, what we are basically saying is that, okay, we don't want this to be animated, with the keyframe animation, but we want this to be animated with some rules of physics and constraints between those bones, right? Okay, so how we do this stuff? We click on our character 3D model. We go here to 3D object, and then we say create ragdoll. And if you already have your rig ready and named in a nice way, you basically here just define, you're telling actually Unity, what are, the joints for some specific stuff. So for example, for pelvis, we don't have the pelvis named here, but we can use some approximate. For example, hips is going to be here, quite good approximate. And then for the left hips, what we're going to do is use this joint. And then for the left knee, we will use this left leg. And then for left foot, we will use left foot. And then the same thing for the right hip and right leg and right foot. Hopefully I'm not doing any mistakes because I'm kind of hurrying right now. So yeah, let me just connect also the arms. So the arms are under here, these spines. So we have the left shoulder, and here we have the left arm. And then, yeah, this is kind of elbow. So yeah, we can go like this. And let me just connect these two also. Okay, then we also need to have some middle spine here, and then connecting the head, which is probably here on the neck, hopefully. And at the end, we just define the, let's say, a total mass of our character. So you can play around with this later, but for now, I'll just use 50, and I will click create. And you notice what will happen after is Unity will actually add these colliders on these bones, right? And you can see the colliders here. And it will also add the rigid body. So this means that these bones are now actually following the rules of physics. And we also see that now we have some character joint here, which is basically, defining some constraints between different bones. For example, the elbow joint, can just move in this kind of direction, right? But it cannot move like this, right? And this is really it regarding the ragdoll effect. So now if we go to the play mode, if we set up everything correctly, you will see our character falling down in some nice ragdoll effect. Yeah, it's not really it because it's still playing some animation from the animator. So let me just disable the animator here. Yeah, now our character is actually falling down. And yeah, this is what happens when you're following the rules of physics and once you're dead. So yeah, you can play around with this. You can also like to see kind of, different stuff. For example, if he falls down on some cube, for example, you will usually get some nice, nice looking effect with this character. So yeah, let me try this also. And enter play mode. Yeah, this is what happens. So yeah, this is basically how you create also the ragdoll. And yeah, what you can also do is is combining these things. So kind of you can animate your character with a keyframe animation, and then once he dies, for example, you can switch to the ragdoll effect. Of course, you will need some code for this, but it's not that much, right? And the most of the work is already done with this Unity physics and all that stuff. So yeah, that was the ragdoll, and yeah, that's mostly it regarding this presentation. Hopefully it was interesting for you guys, and yeah, it was a little bit more than 1 hour, but hopefully you enjoyed it, and I really hope that you will be able, to know what kind of stuff you can use in your future projects, and hopefully I spared you some time which you would spend by maybe inventing some of the things which are already implemented in the Unity. So thank you for the attention, and yeah, if there are any questions, you can go here, or I guess Rok will also say something, right?
Yeah, thank you, Miha. It was really like a cool talk. You went through like some like really nice, let's say, quick hacks or like quick prototypes. Like it's really cool. And yeah, there was already some questions in between your talk, so I'll just go like through them. So I think first was from Dani, which asks like, can the scale of the object affect game performance? Like having the objects like scale like from 0.0.25 or like having their scale more than 1,000?
Yeah, so that's a quite good question. Actually, what's most problematic usually with the scale is that regarding performance in Unity, you have two techniques for decreasing the number of draw calls. They're called like dynamic batching and static batching. And if you would have different kind of object with different scales, the scale can break the batching, right, which would introduce more draw calls, and more draw calls are usually bad for the performance. So basically, in this case, it can affect the performance, and then also, yeah, basically that's the main reason, like when the scale can impact that performance. To keep it simple.
Yeah, thank you. I think that answered the question. So next one is from Martin. What would be the best way to like smoothly transition to an animated state from non-animated state ragdoll character? Like something that you already like mentioned more at the end. What's your like best approach for this?
Yeah, I'm not really sure what would be the best approach, because in reality, I wasn't working with this in production-wise project. But what I would like guess, from my head, basically, it would be just trying to play around, with some forces, maybe, in order to achieve the desired effect based on the previous animation that you were playing. But yeah, more of that I really sadly cannot say. But it's an interesting problem for sure.
Yeah, that's true. And let's move on the next one, which is a little bit longer. So the next one is like, it's from Sheshmeister. He's asking like, he's working with the high definition render pipeline and a third-person camera, the Cinemachine, like something similar that you had, but you had like with the 2D. And he's asking, he has the directional light which falls on the character, and wait, sorry, I'm just reading the question, which it's a little bit longer. Yeah, he has a directional light which falls on character and illuminates the character from direction it falls on it. But when the camera point of view is the other side, the character is dark. So, for example, if character is facing directional, wait, sorry. sorry, the character is facing directional light. The camera is looking at its back, at the backside of character. So, and he asks like, how is this resolved in the games? Do you add another illuminate character, or do you add like ambient light or so on?
Yeah, basically. So, yeah, it actually depends on what you want to achieve, right? Yes, if I understood correctly, the problem is that when the character is faced the other way around, right, that the lighting is not that good, right? Which is like the usual problem. So basically, you can you can use probably like what you would want to do, is maybe using a different set of lights, and know that in Unity you have plenty of different options for the lights. So for example, you have this light probes, for example, and then you have this point lights also. So maybe what I would suggest you that you try to experiment also with different kind of lighting techniques in order to find out what works the best for your game. But it's really hard to answer because there is no generic answer for this, because it all depends on what kind of game you're making. But the bottom line is I would suggest you that you play around with different lighting types, not maybe just one directional light, and see what works for you.
Thank you. And I have like just like few questions while we wait if there like somebody else like some other questions. So one question that I wanted to ask you, like do you use any of like the production tools like that using like for like bigger games, also in like smaller games, or like vice versa? You know, that you use some, I don't know, some like you showed Pro Builder and like you showed Cinemachine. They also use this kind of like techniques also in like large scale projects in like production wise.
Yeah, I mean, like personally, in like my professional life, I'm a bit usually skeptical about those kind of stuff, right? Because like you don't know, like you need to measure the performance and stuff like that. And like professionally, I'm working for mobile games, you know, so maybe not all this stuff are actually appropriate for the mobile. But for sure, like at least in some, you know, personal projects where, for example, you know, it wouldn't be really problematic, you know, if, for example, the game will not work on one device, or, for example, when you're doing some stuff for example, for the game jam or something like this, you know, it's like, or to prototype something, you know, to play around with the game mechanics or something like this. For this, I'm quite heavily relying on this stuff. But for production-wise, usually for all these tools, you can use them, you know, but it's connected also like with what other things, what do you need from the other plugins, right? Because maybe, you know, maybe some plugin, you know, the performance of some plugin will be maybe taking, I don't know, you know, 20% of all your resources, for example. And then if you don't need, you know, the rest of your resources, then you're fine, right? But if your game that you're making is heavily reliant on the resources, right, and you don't have a lot of resources available, then maybe, you know, it's worth, you know, investing maybe 1 week, you know, to solve some problem, you know, which is already solved by the tools that I showed. But then, you know, just do it in a way, you know, that it's really performant for your specific case, you know. So yeah, I would say that in production projects, personally, I am a bit usually distant from these tools, but for prototyping and game jams and all this kind of stuff, I am using this a lot.
Nice. That's really detailed answer. Like one question that also like goes on top of that answer is like, do you have like any like set of like pre-built like scripts or like macros or like stuff that you use like on larger projects or like maybe on game jam games? Like, do you have like, I don't know, like some sets of like, I don't know, like, okay, this is for character controller, this is for animations, this is for something like that?
yeah, like what I'm usually doing is copy pasting stuff from my previous projects, basically. But I saw some guys already like having like a dedicated, prototyping projects where you have everything, that you usually need, some set of tools, just like a proper handyman, and then you just have everything ready, So yeah,
kind of like a sandbox, right? Kind of like a sandbox
exactly.
project.
This is like really useful to have. Like you would be surprised how much of the stuff you can do if you have, let's say, tools already in your project.
And one last question, like from me, and then if there are no questions, I guess we can wrap up. I'll also check again through all of the sites on YouTube and Facebook and so on. So yeah, last question from me is like, what are like some, let's say, traps or like that you experience on these like game jams? Like, because for me personally, I know that sometimes on game jams, I'm like, oh, I want to do this by myself. I won't use any of the pre-built tools. I will just go, I'll just do like a custom integration, and then it takes me like, I don't know, 1 day out of 2 days for like having this tiny little bit, I don't know, tiny shader or like tiny stuff there, and it's like not useful at all. Like, what would you say like that's for you? Is like, what's like your traps that you can try to avoid, or like that you saw from experience that's not that good?
Yeah. Yeah, it's a good question. Thanks. Like for me, my biggest trap, and this is not just on the game jams or some projects like this, is also in professional life. It's the time planning. Because the time planning is hard. Also like in professional life, sometimes you do a quick estimate how much things something will take you. And at the end, of course, it's much more than you anticipated at the start, right? And where the time planning is really important is especially on the projects which are really time constrained. For example, the game jam, right? Where you have maybe 1 or 2 or 3 days, depending on the game jam that you do your stuff, right? And especially, when you don't have a lot of experience, it's like I saw it many times, that people were like, this will probably take me, just a few minutes, and at the end it's like 3 hours, and then if that thing happens to you like 5 times on the game jam, right? Probably then at the end you do 30% of everything that you wanted to do, right? And then sometimes it's not really a pleasant and funny experience, and then people need to crouch and not sleep and things like that. So yeah, to me personally, like game jams and different hackathons and projects like this are all about the fun, right? And I'm having fun when I'm not stressed, right? And when I'm not stressed is when I do my time planning right. And yeah, just my advice would be to really, try to be, let's say, pessimistic while you're doing the planning, in order to be able to finish your things in the right time. And that's it.
Thank you. That's I think great advice. Like I think that's a lot of like, especially developers, like we overestimate like some stuff. It's like yeah, this is gonna be like half an hour, like, and then like bam, 12 hours later.
Yeah, exactly. And this happens also then when you have like 5 or 10 years of experience, So it's really even more harder, for the guys who are just maybe with 1 year experience, for example. It's much harder for them, right? So, yeah.
I think that's it. We don't have any more questions. Thank you again, Miha, for coming and like really having like in-depth conversation. And I think we'll finish here. One more thing that I want to like mention, like join us on like Discord. Like you can also like go on Facebook page and like sign up for the event. We'll post here like daily stuff. And tomorrow we have presentation from Žiga Pavlovic, who will talk about innovative controllers, which is like basically like he uses a lot of like VR and some Raspberry Pis and other stuff. And yeah, and that's it. And see you tomorrow.
Yeah, also from my side, thank you for your attention and see you.